So indeed, I'm speaking on behalf of a group of researchers, including Valery Kryukov and Tatiana Tagaeva. And we are going to draw upon some of the previous studies conducted by our institute. And the objective of this research, or this study rather, is to consider how global climate agenda will impact the development of countries, but rather of individual regions. And I understand that Vladimir Plyzhov later is going to deliver a similar kind of report, though about a different region. Now, we're usually talking about the impact of climate on national economies. And climate changes do create constraints as well as opportunities in terms of development of individual regions. The structure of my presentation is shown here. We'll start by looking at anthropogenic impact on Siberian environment. It will be a kind of a general overview first, then a look at Siberia. And after that, given the time constraint, I will turn directly to the impact of decarbonization or low carbon development on Siberian economy.
Вопрос, собственно говоря, который является в центре этой конференции, безусловно, важный, но является не единственным, достаточно серьезным вопросом.
The issue that is central to the present conference is very important for Russia, though by far it's not the only major challenge Russia, and in particular Siberia, is facing. So, for example, this slide lists some of the key characteristic features of Russian Siberia. And here, when I say Siberia, I mean everything to the east of the Urals Mountains. So, for those who know Russian administrative structure, it includes the Siberian and Russian maritime federal regions. So, for example, the condition of atmospheric air, according to Rosgidromet, or Russian Hydrology and Meteorology Institutes and Watchdog, well, we actually have quite a bunch of cities where maximum permissible concentrations are exceeded. Well, we have 36 cities like this, and 10 of them are located in the European part of the country and the rest in Siberia. You may see that actually some of them are quite large, which means that environmental issues are pretty pronounced for the majority of people living in Siberia. Issues with water resources are also numerous. Siberian rivers tend to have pretty high levels of pollution. Something else I should mention, which actually shows very vividly that the development happening in the European and, shall I say, in the Asian parts of the country are pretty different, and the impact they are having on the environment also differs a lot. So the start of another raw materials or a commodity super cycle, which we're starting to see right now around the world, and we don't really know if it's going to continue or not, but it looks like we are at the start of a new super cycle. So extractive industries in Siberia over the past 10 years have started growing rapidly, and this naturally meant a significant increase in terms of their footprint, both for the biosphere and for the Earth. Actually, we're saying that the waste they are generating is growing almost exponentially over the past 15 years. And these charts are showing pretty clearly that is particularly pronounced in Siberia. And we in Siberia are very much troubled and concerned by it all. Now, the left-hand chart, the central dark blue line there is GDP index in comparable prices. So you see it's, well, it has grown from 1 to nearly 2, but note the increase in the two top lines, which represent creation of waste in consumption and manufacturing. And light blue is billions of tons, and gray is kilos per dollar of GDP. Now, people often say that Siberian forests are great carbon traps. Please note, however, that the majority of Siberia actually sits in a climate-wise very challenging part of the world. So the parts of Siberia which are good, say, for agriculture or some economically sensible activity tend to be in the south, while lots of extractive industries are operating in the north, where the environment is particularly fragile, and it's there that concentration of our activities tends to be very high. Now, I guess people present at this conference today know a lot about Siberia. So I go very briefly by saying that Siberia actually has lots and lots of extractive industries. The lion's share of this raw materials extracted is related to the kind of minerals that are the focus of global climate agenda. So we're talking hydrocarbons, well, carbons and ferrous and non-ferrous metals. So global energy transition will naturally create risks, because if alternative energy, if renewables continue growing and developing, then over time, non-renewables market segment can be expected to shrink, which is not really happening right now. What we are seeing at the moment is a redistribution of the global market, which is sort of creating some opportunities for Russia as well. Now we can think back to what has been happening lately to coal in Europe. So Europe has been substituting its own coal production with external coal supplies, but it stays equally dependent on coal. And will stay dependent on coal until European plants change their fuels, which means that Russia, can still provide its coal to the European market, given the huge demand for it there now. What needs to be taken into account here, though, as well, is the huge distances. So Siberian economy actually depends on transport a lot. And the transportation industry will remain one of the key emitters of carbon dioxide for at least a decade. There are some regions on this planet where, for example, services sector dominates in emissions, or very high value added manufacturing. It's not the case of Siberia, though, where value added is low, but volumes are colossal. So this decarbonization agenda will actually spell doom for a Siberian economy, given that value added there is low, transportation costs are significant, and transportation related emissions are high.
Конечно, то, что связано с образованием.
Another characteristic feature of this energy transition in Siberia is related to evolution, so to speak, of greenhouse gases. So even if we do not use a very precise assessments of GHG emissions for individual regions, if we're simply looking at national cumulative numbers, and actually the left-hand pie chart shows specific fuel consumption at boiler houses and power plants in 2020, stratified by type of fuel. So blue is gaseous fuel, orange is coal, and gray is other types of fuel. So Russia is left-hand pie chart, European part of Russia is central chart, and right-hand chart is Siberia. So the share of CHPs in Siberia is actually lower than in the western part of the country, but it's important to understand what explains this difference. And this is what the bottom chart shows pretty convincingly. We have a sizable share of it coming from coal-fired generation, unlike the European part of the country, where gas-fired CHPs dominate the scene at nearly 90%. Obviously, coal plays a very important role in GHG emissions. Well, in fact, coal is a more expensive type of fuel in the long run. I'm sorry. So the given structure of of Siberian energy mix, Siberia will not be very competitive, particularly if strict regulation is endorsed, if fiscal stimuli are brought in to minimize GHG emissions. Another important question is how Siberian economy is integrated in supply chains. Had we been considering Siberia as an island, isolated region, climate regulation would not be much of an issue, right? Because any fiscal changes would result in changes in livelihoods, increasing cost of living, and further depopulation of the region. Or maybe the government would decide to stem the depopulation with subsidies or by infusion of resources in some other manner. However, Siberia is part of both national and international supply chains. Therefore, Siberian economy will also be exposed to lots of competition-related factors, not just decarbonization agenda. So I'm referring here to calculations performed by Sergei Petrov on the basis of Rostat, IEF RAS, and other data sets. So they're not taking Tyumen here into account because apparently they didn't really have precise data for EAF steel produced in Tyumen. But Mr. Petrov actually tried assessing total emissions of greenhouse gases coming from ferrous metallurgy or ferrous metals companies in the Asian part of Russia. And as regards the bars, the left-hand one is steel production, central one is basic oxygen furnaces, and the right-hand one is electric arc furnaces. So please note that indeed we have some very badly polluting plants in this region, and they're quite bad pollutants even based on bottom-up estimates. At the same time, they're part of international supply chains. The steel they produce will then be used in production of stuff for Russian railroads, and some of it will be exported. And as regards BIF steel, a basic oxygen furnace steel, again, its geography of sales is quite substantial. So since Russian metals companies are a part of the global supply chain, with tighter regulation, they will lose their competitiveness and may be substituted by others. In order to avoid that, we naturally need to review our operational processes or maybe the way the supply chains are designed. And it's a well-known fact that Siberian economy was designed from the very beginning to run on coal, and it does employ lots of things. Yes, I'm aware that time is up, so I'll try to go very quickly through the list of institutional changes required in order to support a smooth, seamless reduction in GHG emissions. Let me just skim through these slides because I understand that my time is up and I cannot really read through them. But I should probably focus on the last chart here, which in my opinion is quite useful, at least in terms of providing a systemic look at the kind of opportunities which are still existent for Siberian producers. Oh, no, I'm sorry. It's not for producers, but rather for the, educators and researchers in Siberia. So there are lots and lots of various institutions located in Siberia, and they can be involved in development of environmental responsibility through education, nurturing, raising awareness, as well as assessment of the impact of climate change on public health, and research into climate changes and CO2 absorption processes, and so on. Thank you very much for your attention. I should wrap up here.